Okay. Let's reconvene here. You want to keep working on your own, you can mute your computer and keep working if you want. But we'll move along. So does anybody want to walk me through the steps of solving this problem?
That depends. Can I confirm I got the right answer? Someone
Sure.
else sounded way more confident. Let's let them do it.
Yeah,
I said
yeah.
sure questioningly.
Yeah, you want to go ahead, Kyle? Or yeah, I see Jacob's chiming in too. You why don't you start us, Kyle, and then yeah, maybe you can take over if you want, Jacob.
Yeah, so I said that let u of xt be capital F of x minus ct only, because you know that those are the only characteristics that contribute. Leftward going characteristics don't.
That's a good
and
point.
So f of negative, so using the initial, or not initial condition, boundary condition, you get f of negative t equals sine t. And so if you make a simple variable change, y equals negative t for y less than 0, and we can use that for u of x and t to say that that equals sine of t minus x for x greater than t, and then we already established that u is 0 for x less than t. And so I find that it's continuous but not C1.
Okay, just by taking the derivative.
Yeah, because the limit as x minus t goes to 0 from the right of, the derivative negative cosine t minus x is negative 1.
Mm-hmm. Yeah, so your final solution is like sine of t minus x for x less than t. Of course, this has to be greater than 0 too, and then 0 for x greater than t. Yeah, and then you just take the derivative and take the left and right limits, essentially. Or it would work whether you took the x or the t derivative and took the, left and right limits, or, above and below limits. Okay.
Oh, right, I had my signs flipped. I said that it was sine of t minus x for x greater than t.
Oh, yeah, that's fine, yeah. Okay, so we kind of whipped through that. I'll just email out these solutions so that people can take a look. But yeah, I mean, so to Kyle's point, right? U is just 0. I mean, we've already said in part A that U is 0 when x is t. So we're done with that case. So when x is less than t, right? And this is actually a very helpful insight that comes from drawing the characteristics. If you're in this region here, right, you know that you have a characteristic that flows to the left, right? Which would be this is like the x plus t characteristic. So you know that that's always going to access data that is 0 in this region. So for that reason, right, this typical u equals f of x minus t plus g of x plus t, right? That thing is just going to be equal to 0, okay? Because if you move from this position according to this characteristic sort of backward in time, you're always going to hit places where it's the data are 0, right? So you only need the f of x minus t term there. You can go the long way around and say, well, I'm going to solve for both of these things, right, using the typical approach, right? But yeah, but at the end of the day, it's only this term that should matter, right? And then yeah, what Kyle said essentially is that the only thing I really need to look at, right, because the only thing that's going to contribute non-zero, right, is going to be this third condition. U of 0t is equal to h of t, which in this case is equal to f of minus t. So this just implies that f of y is equal to h of minus y, which in this case is sine of minus y or minus sine of y, if you like, right? And so then u of xt is equal to just sine of t minus x in this region on x goes from 0 to t. And so in general, right, this is what we wrote, sine of t minus x in this region, and x as 0 when x is greater than t. So then for continuity, right, we can just check the limits, the limit as, let's say x goes to t from above and below, right, is going to be the limit that you take of sine of t minus x, or 0, right? And that's always going to be 0, right? Because sine of 0 is 0 and 0 is always 0, okay? Now the continuously differentiable part, right? You need to compute u sub t, which is going to equal 0 and then cosine of t minus x, right? So I can just check one of these conditions, and if it's violated, boom, then I know that I don't have continuous differentiability. So you can take the limit as t goes to x from above, right? Let me make sure this is right. Yeah. T goes to x from above, right? Of cosine of t minus x, and you get 1, whereas the limit as t goes to x from below would be this part. So that's going to be 0. So these are not equal. So it's not C1. Okay. So again, the idea here is that we have a split domain, right? And we're approaching from both sides. We're computing u sub t in this case. And we just want to see if their limits above and below match, right? For continuous differentiability, you would also need to check that. But once you know one condition is violated, you're done. You don't need to check the other one. Given limited time, you can just move on. Okay. But the other one is violated too. Okay.